Hello dear students, my name is Rahul Chugh and I welcome you all to my YouTube channel Farmavers. Today we will going to see some important objective questions from the topic Emulsions, Biphasic Liquid Dosage Forms. This is basically the part 1 from this topic. Part 2 will going to be released soon. So let's get started. So moving on to the very first question of our today's session, and that is the amount of castor oil in commercial emulsion ranges from options are 1 to 10%, 30 to 50%, 70 to 74%, 80 to 85%. So जो commercial castor oil emulsions होते हैं that typically contains 30 to 50% of oil. So we can say option B, that is 30 to 50% is the correct answer of this question. Moving on to the next question, a cationic surfactant that is used as a disinfectant. We have to identify एक cationic surfactant जिसे disinfectant के तौर पे भी यूज किया जा सकता है. ऑप्शंस दिए गए हैं बेंजाइलकोनियम क्लोराइड, हेक्साक्लोरोफीन, क्लोरोजाइनॉल, प्रोफ्लेविन. So जो बेंजाइलकोनियम क्लोराइड होता है that is widely used as a cationic surfactant and disinfectant due to its antimicrobial activity. So we can say option A, that is benzailconium chloride is a cationic surfactant that can be used as a disinfectant. Moving on to the next question, emulsions containing more than two phases are called. Options are mixed emulsion, heterogeneous emulsion, homogenized emulsion, multiple emulsion. So multiple emulsions like water in water or oil in water in oil involves inner and outer phases of the same type separated by an intermediate phase. So we can say option D, that is multiple emulsion, is the right answer of this question. Means emulsion containing more than two phases are called multiple emulsions. Moving on to the next question, which one of the following is a non-ionic emulsifying agent? Options are yellow paraffin wax, bee wax, liquid paraffin या spans. So जो spans होते हैं they are sorbitol esters and are non-ionic surfactants oftenly used in water in oil emulsions, while paraffin waxes lack emulsifying properties. So we can say option D, that is spans are non-ionic emulsifying agent. Moving on to the next question, the HLB system was developed by. Options are Griffin, Stokes, Delavalle, none of these. So hydrophilic lipophilic balance system, that is HLB system, is the key in selecting the emulsifiers, and it was developed by William C. Griffin in 1949. So we can say option A, that is Griffin develops HLB system in 1949. So option A is the correct one for this question. Moving on to the another question. Example of anionic surfactant is, out of the given four options we have to identify कि इसमें से anionic surfactant का example कौन सा है. ऑप्शंस दिए गए हैं ग्लाइसिन, सोडियम डोडेसाइल सल्फेट, ट्राइएल्काइल अमोनियम, पॉलीइथाइलिन ग्लाइकॉल. सो जो सोडियम डोडेसाइल सल्फेट होता है जिसे हम SDS बोलते हैं शॉर्ट फॉर्म में, इज अ क्लासिकल anionic surfactant and it is widely used in cleansing and emulsifying application, while glycine is a non-surfactant, trialkyl ammonium is a cationic surfactant, and PEG, that stands for polyethylene glycol, is a non-ionic surfactant. So we can say option B, sodium dodecyl sulfate, is an example of anionic surfactant. Moving on to the next question, spans and twins are. Options are highly polymerized manuric acid anhydride, phospholipid, polyoxyalkylene derivatives, glycosides. So जो spans and twins होते हैं they are polyoxyalkylene derivatives of sorbitol esters used as a non-ionic emulsifying agent with different HLB values. So we can say option C, that is polyoxyalkylene derivatives, is the correct answer of this question. Moving on to the next question, sodium lauryl sulfate, that is also called as SLS, is option R, cationic surface active agent, ampholytic surface active agent, non-ionic surface active agent, anionic surface active agent. So sodium lauryl sulfate carries a net negative charge in a solution, which makes it an anionic surfactant, and it is commonly used in shampoos and toothpaste. So we can say sodium lauryl sulfate is a anionic surface active agent, that is option D. Moving on to the next question, in formulation, to facilitate the wetting of insoluble solids. Which agent is used? Options are suspending agents, flavoring agents, wetting agents या none of these. So जो wetting agents होते हैं जैसे कि surfactants that reduces the interfacial tension between solids and liquids, helping hydrophobic powder to become dispersed. So we can say option C, that is wetting agents are used in formulation to facilitate the wetting of insoluble solids. Moving on to the next question. Liquid drops or gas bubbles are always spherical in shape due to options दिए गए हैं वॉल्यूम टेंशन, सरफेस टेंशन, ग्रेविटेशनल फोर्स, मैग्नेटिक फोर्स. सो जो सरफेस टेंशन होती है that minimizes the surface area which results in spherical shapes. So we can say option B, that is surface tension is responsible for liquid drops or gas bubbles to be in spherical shape. Moving on to the next question. Dilatant material is termed as options दिए गए हैं shear thickening system, shear thinning system, plastic system, pseudoplastic system. So जो dilatant system होते हैं that increases the viscosity with shear, the opposite of shear thinning behavior. So we can say option A, shear thickening system are termed as dilatant material या dilatant material is termed as shear thickening system. So moving on to the next question. Fluid moves in a direction opposite to the sedimentation movement. So basically this is a statement and we have to find out that among these four options which define this statement. And the options are settling, elutriation, centrifugation, precipitation. So in elutriation, the fluid flows upward carrying finer or lighter particles while heavier particles settles down. We can also say that elutriation separates the particles via counter current fluid flow opposite to sedimentation, while settling is same as that of sedimentation. Centrifugation uses centrifugal forces, not fluid flow, and precipitation is the formation of solids from solution unrelated to fluid direction. So we can say the fluids moves in a direction opposite to the sedimentation movement is called elutriation, that is option B. Moving on to the next question. How surfactant will facilitate or aid or help the wetting of hydrophobic materials in liquid? Options are by decreasing the solid liquid interfacial tension, by increasing the solid liquid interfacial tension, by decreasing the solid liquid interfacial tension, and by increasing the solid liquid interfacial tension, or none of these. So surfactant basically reduces the interfacial tension between a hydrophilic solid and a liquid. This lowers the contact angle and allowing the liquid to spread more easily, that is wetting of the surface. So we can say option A, by decreasing the solid liquid interfacial tension, a surfactant will facilitate or help the wetting of hydrophobic materials in a liquid. Moving on to the next question. Zephyran is a dash surfactant. Options are anionic surfactant, cationic surfactant, non-ionic surfactant या ampholytic surfactant. So जो Zephyran है is a trade name for benzalkonium chloride, and we all know कि benzalkonium chloride एक हमारा cationic disinfectant है and surfactant है. So we can say option B, that is cationic surfactant, is the correct answer of this question. Moving on to the next question. The most significant temperature effect on emulsion stability is, options are creaming, caking, cracking, phase inversion. So the phase inversion होता है that occurs when an emulsion shifts from oil in water to water in oil or vice versa due to temperature fluctuation. So we can say option D, that is phase inversion, is the most significant temperature effect on emulsion stability. Moving on to the next question. Example of a non-ionic emulsifying agent. We have to find out the example out of these among four options कि इसमें से नॉन आयनिक सर्फेक्टेंट इमल्सिफाइंग एजेंट कौन सा है. ऑप्शंस दिए गए हैं सोडियम लोराइल सल्फेट, पॉलीऑक्सी इथाइलिन सॉर्बिटन मोनोओलिएट, सेटाइल ट्राइमिथाइल अमोनियम ब्रोमाइड, डोडेसाइल pyridinium chloride. So polyoxyethylene sorbitan monooliate, also known as 2-in-80, is a non-ionic emulsifier used in oil and water emulsions. So we can say option B, that is polyoxyethylene sorbitane monooliate is a non-emulsifying agent. Moving on to the next question. Which is not an emulsion instability problem. Out of the given 4 options, emulsion instability problem इसमें से कौन सी नहीं है? Options are creaming, phase inversion, cracking, flashing. Flashing is basically unrelated to emulsion, while others, that is creaming, phase inversion, cracking, are recognized as emulsion instabilities. So we can say option D, that is flashing, is not an emulsion instability problem among the 4 given options. Moving on to the next question. Which of the following is not used an emulsifying agent? Out of the given 4 options, we have to tell कि इसमें से emulsifying agent के तौर पे कौन सा यूज नहीं होता. ऑप्शंस दिए गए हैं surfactant, hydrophilic colloids, electrolytes, finely divide solids. So जो हमारे electrolytes होते हैं, they do not stabilize the emulsion but may destabilize them. So they are not used as an emulsifying agent, while the other listed, that are surfactant, hydrophilic colloids, and finely divide solids, assist in emulsification. So we can say option C, that is electrolytes, are not used as an emulsifying agents. Moving on to the next question. In relation to emulsion, the formation of a layer of relatively concentrated emulsion above or below the surface is known as. Options are cracking, creaming, mottling, phase inversion. So जो creaming होता है is basically a reversible process in emulsion where the dispersed phase rises or settles, leading to a layer separation but not complete breakdown. So we can say creaming is the right answer of this question. So moving on to the next question. To identify the emulsion type, which of the following tests are conducted? मतलब out of the given 4 tests, we have to tell कि emulsion type को determine करने के लिए, identify करने के लिए हम कौन से test conduct करते हैं. And the options are dilution test, dye test, conductivity test, या सारे, या all of these. All these 3 tests helps to differentiate between oil in water and water in oil emulsions by examining the miscibility, staining, or conductivity behavior. So we can say all these 3 tests, dilution test, dye test, and conductivity test, are used in identifying the emulsion type. In dilution test, it determines if the emulsion mixes easily with water or oil. Dye test, in this, water soluble dye is disposed in oil and water emulsions, oil soluble dye is in water and oil emulsions. Conductivity test, in conductivity test we take the oil and water emulsions to conduct electricity, while water and oil emulsions do not. So we can say option D, that is all of these, is the correct answer of this question. Moving on to the next question. Which one of the following is used as an antimicrobial preservative? Out of the given 4 options, we have to tell antimicrobial preservative के तौर पे कौन सा यूज किया जाता है. ऑप्शंस दिए गए हैं प्रोपाइलिन ग्लाइकॉल, प्रोकेन हाइड्रोक्लोराइड, प्रोपाइल हाइड्रोक्सिल बेंजोएट, sodium hydrogen carbonate. So it's a propyl paraben with antimicrobial properties widely used in pharmaceutical and cosmetical formulation. So we can say option C, that is propyl hydroxyl benzoate, is used as an antimicrobial preservative. Moving on to the next question. Colloidal dispersion of liquids or solids in gases is. Options are aerosols, emulsions, creams, या suspensions. So जो aerosols होते हैं, they are colloidal system where fine liquid or solid particles are dispersed in a gas, often air. So we can say aerosols are the system or the colloidal system in which liquids or solids are disposed in gases. Moving on to the next question. Ratio of oil water gum for preparing an emulsion using in volatile oil is. Options are 2:2:1, 4:2:1, 3:2:1, 1:1:2. So for volatile oil or essential oil, a 4:2:1 oil water gum ratio is required, as they required less emulsifier than fixed oils. So we can say option B, that is 4:2:1, is the correct answer of this question. So moving on to the next question. The phase inversion in an emulsion involves. Options are change of emulsion type, complete separation of two phases, formation of aggregates, या upward movement of floccules. So जो phase inversion होता है, it is a phenomena where an oil and water emulsion changes into water in oil or vice versa, usually due to the composition or the temperature fluctuation or temperature changes. So we can say the phase inversion in emulsion involves change of emulsion type, that is option A is the correct answer for this. Moving on to the next question. The shelf life of a pharmaceutical product is computed by out of the given four equations or laws which tells you about the shelf life of a pharmaceutical product. Options are Fick's law, Arrhenius equation, Higuchi's equation, Noyes-Whitney equation. So Arrhenius equation या Arrhenius model tells you about the effect of temperature on reaction rates. It helps in predicting the drug stability and its shelf life, while the other equation, that is like Fick's law, it is related to diffusion. Noyes-Whitney equation related to dissolution rate, and Higuchi's equation is related to the release of the pharmaceutical product. So we can say the shelf life of a pharmaceutical product is computed by using Arrhenius equation, that is option B. Moving on to the next question. The phase inversion temperature, that is PIT, of a surfactant is one at which options are surfactant form micelles, surfactant melts, the hydrophilic and the lipophilic properties of a surfactant are balanced, surfactant undergo inversion. So at PIT, that is phase inversion temperature, the surfactant shows the equal affinity for oil and water, and it is very much critical for forming a stable emulsion. So we can say at the phase temperature, the phase inversion temperature of a surfactant is one at which the hydrophilic and the lipophilic properties of a surfactant are balanced. So option C is the correct answer of this question. Moving on to the next question. The type of emulsion may be determined by options are leakage test, conductivity test, toxicity test, bubble point test. So conductivity test helps in distinguishing of emulsion type based on whether a conductor is the continuous phase or not. So we can say a conductivity test is used to determine the type of emulsion. So moving on to the next question. Which one is not related to the physical instability of an emulsion? So we have to find out of the given four options इसमें से कौन सा physical instability of an emulsion से related नहीं है. Options are phase inversion, creaming or sedimentation, Ostwald ripening या oxidation of the components. So जो oxidation है, it is a chemical degradation process, while others like phase inversion, creaming or sedimentation, and Ostwald ripening are comes under the physical instability. So we can say option D, that is oxidation of component, is not related to the physical instability of an emulsion. Moving on to the next question. On a commercial scale, emulsions are prepared by options are dialysis, freezing, homogenization, centrifugation. So homogenization forces liquid through narrow opening to produce fine, stable emulsion efficiently, while dialysis, freezing, and centrifugations are not standard for emulsion preparation. So we can say option C, that is homogenization, is used for the preparation of emulsions on a commercial scale. Moving on to the last and the final question of our today's session, and that is, to increase the viscosity of a liquid, which of the following agents are used? Options are PVP, benzyl ammonium chloride, sodium carboxymethyl cellulose, या all of these. So जो हमारा सोडियम कार्बोक्सीमिथाइल सेल्यूलोज होता है, it is a hydrophilic polymer and a commonly used thickening agent in liquid dosage form, while PVP, which stands for polyvinyl pyrrolidone, that act as a binder, and benzyl ammonium chloride, that act as a preservative, do not primarily thicken the liquid. So we can say option C, that is sodium carboxymethyl cellulose, is used to increase the viscosity of a liquid. So that's it for today's session. I hope these MCQs will going to help you to sharpen your preparation. This is basically the part 1 from the topic emulsion as a biphasic dosage form. Part 2 will come soon on this topic. And if you like the video, then don't forget to like, subscribe and hit the bell icon for more pharmacy insights. Thank you.